NASA has recently revealed an ambitious new plan that could transform the future of space exploration by dramatically shortening the travel time between Earth and Mars. Traditionally, missions to Mars have taken astronauts anywhere from 6 to 9 months, relying on chemical propulsion systems to power spacecraft on their journey across the vast expanse of space. However, in a bold move to accelerate space exploration, NASA is now developing a revolutionary propulsion technology known as the Pulsed Plasma Rocket (PPR). This cutting-edge technology has the potential to cut the travel time to Mars by more than half, reducing the journey from several months to a mere 2 months. This breakthrough could completely reshape how we approach interplanetary travel, allowing humans to reach Mars faster, more efficiently, and with reduced risks. The pulsed plasma rocket works by using high-energy electrical pulses to ionize a propellant, creating plasma. Once ionized, the plasma is expelled at high velocity through magnetic fields to generate thrust. Unlike conventional rocket engines, which rely on the combustion of chemical propellants to produce thrust, the PPR operates through electricity, offering a highly efficient and sustainable alternative for long-duration space missions. The plasma propulsion system creates a consistent, steady thrust over extended periods, allowing spacecraft to gradually accelerate over long distances. This continuous acceleration would enable a spacecraft to reach much higher speeds than conventional chemical rockets, ultimately reducing the time needed to travel between Earth and Mars. One of the most remarkable aspects of the pulsed plasma rocket is its ability to maintain a low but steady thrust over a long period of time. Traditional rockets release all their fuel in one massive burst of energy, providing powerful initial thrust but quickly exhausting their fuel supply. In contrast, the PPR's unique system allows for a consistent push, making it ideal for missions that require sustained propulsion over months or even years. This constant acceleration could be the key to achieving faster travel times across the solar system. In the case of a Mars mission, this technology would allow a spacecraft to travel from Earth to Mars in just 2 months, drastically reducing the travel time and, in turn, the associated risks of extended spaceflight. By cutting the travel time to just 2 months, the pulsed plasma rocket offers a number of important advantages for deep space missions. One of the most significant benefits is the reduction of astronaut exposure to harmful cosmic radiation. Space travelers are continually exposed to high levels of radiation as they leave Earth's protective atmosphere, and the longer the journey, the greater the risks to their health. By shortening the travel time, NASA can minimize the time astronauts spend in this radiation-heavy environment, reducing the overall health risks of long-duration missions. This is critical not only for Mars missions but also for future deep space exploration to other planets and celestial bodies. In addition to enhancing astronaut safety, the reduced travel time would also alleviate some of the physical and psychological challenges that long-duration space missions pose. Extended space travel can have profound effects on the human body, including muscle atrophy, bone density loss, and changes to the cardiovascular system, all due to the microgravity environment. A shorter journey would help mitigate these issues by reducing the time astronauts need to spend in space, allowing them to arrive on Mars in better physical condition. Psychologically, a 2-month journey is far more manageable than a year-long or longer mission, reducing the potential for stress, anxiety, and other mental health concerns that arise during long, isolated trips. The technology behind the pulsed plasma rocket has been under development for several years at NASA, and initial test results are promising. The concept of pulsed plasma propulsion is not new, but NASA's recent advances have brought the technology much closer to being ready for real-world use. Over the years, engineers and scientists have worked tirelessly to refine the systems, improving the efficiency of the plasma generation and thrust output, while ensuring that the rocket can withstand the extreme conditions of space. With continued testing and development, NASA aims to perfect this propulsion system and integrate it into future missions, potentially even setting the stage for the first human crewed mission to Mars. The potential impact of the pulsed plasma rocket extends far beyond Mars missions. While the immediate focus is on reaching the Red Planet, the technology could open the door to a new era of space exploration. This propulsion system could make deep space missions to other destinations, such as the outer planets, moons, and asteroids, much more feasible. The ability to achieve faster travel times, along with the reduced need for traditional chemical propellants, could allow space agencies and private companies to undertake more ambitious missions without the logistical constraints and costs associated with conventional rocket technology. Furthermore, as the technology matures, it could even pave the way for future interstellar exploration, as the principles behind pulsed plasma propulsion could eventually be applied to journeys beyond our solar system. NASA's vision for a 2-month transfer to Mars is part of a broader goal to not only send humans to Mars but also to make interplanetary travel a routine and sustainable endeavor. By developing and perfecting new propulsion technologies like the pulsed plasma rocket, NASA is setting the stage for the next generation of space exploration. The advancements being made in propulsion technology will make future missions more efficient, safer, and cost-effective, and will allow humanity to extend its reach into the cosmos like never before. If successful, the pulsed plasma rocket could be the cornerstone of NASA's ambitious plans for human settlement on Mars, as well as other long-term goals, including the establishment of a permanent human presence on the Moon and the exploration of distant worlds. The excitement surrounding this new propulsion system is not just about reaching Mars faster, it's about the limitless possibilities it presents for humanity's future in space. With faster travel times, more efficient systems, and safer missions, space exploration could become far more accessible, opening the door for a variety of new industries and opportunities. From colonizing other planets to mining asteroids for resources, the potential applications of pulsed plasma technology are vast. As NASA continues to refine this groundbreaking technology, it brings us one step closer to a future where space is no longer a distant frontier but a tangible part of humanity's existence. In conclusion, the pulsed plasma rocket represents a monumental leap forward in space propulsion technology, with the potential to revolutionize the way we travel through space. By cutting the travel time to Mars to just 2 months, NASA is not only advancing our capabilities in space exploration but also paving the way for the future of human space travel. With this new technology,